Let's see if we can read and write our Blackboard to NBT. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, I told you that normally a Blackboard is part of the data that doesn't need to be serialized in our use case. However, between the episodes, I sat back and thought about exactly the same example as I said for a block entity that needs to move from one place to another. Basically, that would be an entity, not a block entity. However, that made me think, what if for some reason a user wants to serialize some type of data inside Blackboard and he needs to track that data between the save and load? Well, normally you would say there are works around it. For example, if a node needs to know a block pause, then put it as a supplier and get that from the block entity or any other logic out there. However, if we want to make our Blackboard work with Minecraft and make it 100% bulletproof, we need to have a way to serialize and deserialize our Blackboard. To do that, we need to sit back and think about this bad boy here, object. Basically, what we are doing right now is adding any sort of data that we want into the Blackboard without caring about the type. And then it's the job of the user to make sure that he is setting or reading the proper value from the Blackboard. If we want to serialize this thing, then the story is different. For being able to serialize and deserialize our Blackboard using NBT system from Minecraft, somehow we need to track the type of the data that we have. Now, the best solution for that is to have our own type of custom registry. And we will have it in this class. It's a little bit more advanced topic. I may not be able to explain things in English, but hopefully it will make sense. The very first thing that we need is a private static final map of string, codec of any type. So we'll call it type registry. Then we have a private static final map of the class of any type with a string, and we call it class2id equals to new hash map. These two will be used to handle our own internal registry system. Then, before put or anything else, we will have a static block, and here I will try to register the predefined types that we will use. So I will say register type of the name int with the integer.class. So we provide the class. And finally, for the codec.int, and that would be it. We will go forward with the rest of them, but before we move forward, I want to have that method. So it will be public static that returns t void register type that accepts a string id, a class of type t, and here we call CLAZZ. That's a classic thing that we use in Java, and then the codec of type t codec. Here we will say type registry, put the ID for the codec, and class to ID, put the class with the ID. So basically we are saying that, hey, for int, we have this codec, and then for integer class, we use the key int. Okay, that will get us away from the errors here. Then we have register type float, register type double, register type not byte, goddammit, you were going good. Register type of long, are you smart enough? Yes, for the codec long. Then we have the boolean, no, you are adamant on adding that. Boolean, and for boolean, we will use class boolean and codec bool. God, forget about the byte. I will delete that one. And he has no idea that I want to use a string. So string, that will be string.class, codec.string. Then I will copy this because this guy will still say byte. And here we want block pause. For the class, we have block pause. And for codec, this time we change things around and we say blockpause.codec. And what's wrong with you? We will add it to dictionary. Another one will be the vec3d. So vec3d, and this one will be vec3d, and again vec3d. Copy this guy 2 times because now we go for I and F, and this will be 2F, not 3F. So 2F and 3I, 3I, and finally 2F. And by doing that, we already covered our custom custom types. However, we gave the ability for the user to call register type as a static method and add it on top of our registry. I can't make this one not a static because then we have problems, but hopefully it will work. And honestly, I don't think anyone wants anything beyond this inside the Blackboard. If you want to, then you need to provide the class, the codec, etc. And this guy is saying convert contents of collection are updated but never queried. Don't worry, we will query it. So after that, we want two private methods here. We have private static string get type ID for object value. And here we say if value equals to null, return null. Otherwise, string ID equals to the class to ID get for the class. Then we say if ID does not equal to null, we want to return the ID. Otherwise, we will look up. So for map.entry for the class of any type, comma string, we call it entry inside our class to ID entry set. We want to check if entry.get not value dot get key dot is assignable from value.class. Basically, we are checking if we can assign the value to this type. Then we say return entry.get key, no, get value this time. And at the end, if everything failed, we return null. The next one, we say private static that returns type T, codec of type T, and get codec. So here we say string type ID. Now here we want to get the codec from type. So we say codec of any type that we don't know equals to type registry, get the type. Then we check if codec is equal to null, throw new illegal argument exception that we say Blackboard colon unknown codec or unknown instead type ID plus type ID. And finally, we return the codec of T to codec. Now, here's the thing. We are unknown. So we are doing a typecast. And here we want to suppress the warning for uncheck. And this will remove that warning there. So far, we have the boilerplate to code our read and write NBT and the codec. However, we want to change this map because we don't need objects anymore. Instead, we will use something called Blackboard entry that we don't have yet. And let's add it first, and then I will come back to the codec and everything else. Inside our base, we need a Java class. We call it Blackboard entry. Blackboard entry will have a public final string type ID and a public final object. We are encapsulating the object here. Then we want a constructor that will accept both of them. And now we need a codec for this guy because anything that needs to be serialized, any class, anything else needs a codec of its own. So we say public static final codec of Blackboard entry, we call it codec, equals to that. So record codec builder dot create instance goes into instance group. And here we want to assign things. So we say codec dot string dot field of. Now the name is type dot for getter. Now here I will not use an easy way. So we say we use entry as a lambda goes into entry dot type ID. And after that, we want the next one. Yes, we will have problem right now because we need to finish things. Codec dot pass through dot field of value dot for getter. And here again, we say entry goes into a lambda, but now I will expand this lambda. And here we say codec of object codec equals to get codec for the entry dot type ID semicolon. Then we say return the codec dot encode start with nbt ops dot instance comma entry dot value after the parenthesis dot result dot or else throw. Means that we couldn't handle the things ourselves. After the parenthesis below, by the way, this is for the for getter. We need to go one parenthesis out. Let's move down. Dot apply instance comma. Now we use a lambda called type comma din for dynamic goes into open close curly parenthesis. And let me see, we want to move it there and put a semicolon and move this whole thing to the start of the line. Now here we want to say codec of object, we call it codec equals to get codec for the type. Then we say object value equals to codec.decode nbt ops.instance comma the din for dynamic. Then we get the result. Then we want to map it to pair colon get first. After that, or else we want null. Finally, we return the new Blackboard entry with the type and value. Now, the biggest problem is that get codec, and it says import static method from codec encoding get codec Blackboard get codec. Let me see which one should we use. Actually, I think it will use the one under Blackboard. Blackboard, hopefully that's the correct one. Looks like not. So if I cut this whole thing from here to here and put it inside Blackboard to make it an internal class, you see that this will work. So it is actually calling our get codec, codec.encode start bad return type in lambda expression nbt element cannot be converted to dynamic of things. So let me go back, paste, and what's wrong with you now? Has private access. Okay, make it public. So now we are back to here. It says bad return type of lambda. So let's see how we can fix this one. If we say nbt element nbt equals to codec.encode start with nbt ops.instance comma entry.value. So far so good. Dot result dot all or else true. Okay, this is good. And finally, we say return new dynamic, and the object here is redundant, I think. And we say nbt ops.instance and the nbt get codec of. No, I don't want that one. I want codec. And I need to say that, yeah, actually, I can inline it. So we say entry.type ID. And this one is fixed. For the next one, it says that required type provided nbt ops, but we need a dynamic capture of anything. So for this one, we get the codec. Let's remove these two lines. Actually, this single line, and instead we say nbt element nbt equals to dynamic dot get value. And then what's wrong here is that it says capture of nothing. Let's typecast it to nbt element, and that will fix that one. Then we say object equal object value equals to codec dot parse using nbt ops dot instance comma nbt result get or throw, or instead of get or throw we can say or else null. This is a better one. And finally, we return that. That was a little bit of codec shenanigans, and don't ask me what's going on. Well, the first thing is obvious. We are just encoding the string. But for the objects, we will use pass-through, and you can look into web for that. And then basically we convert our object to nbt element so that it can be serialized, and we do the reverse. So we get the nbt element, and from the nbt element, we will try to get the object. Now let's go back to our Blackboard, and from top, we will go down because now we have some problems to cover. This one is fixed. Now we need a constructor that accepts nothing, and it will be empty, by the way. The put here says value. However, we can't do it directly this way because remember, now we have things to handle. We say string type ID equals to get type ID for the value. Then we say if type ID is null, then we throw new illegal argument exception. Blackboard unsupported type valued. Here I will add things to that for value, and we say value dot get class get name. That was what I wanted. Dot get name. Otherwise, we want to put a data for the key, but we say new Blackboard entry with the type ID and value. Now for getting t, let me remove all of that. We say Blackboard entry equals to data that get for the key. Then we say if entry equals null, but before that I want to check other things, and entry dot value equals null, either one of them. So or we return null. Otherwise, if not, type dot is instance of entry dot value. Again, we want to return null. At the end, we say return type.cast. Basically, we read the value and we cast it to the type. Get data now returns something different because here we were returning a map of a string and object. However, we want to return a map of string and Blackboard entry now. And here we can say collection dot on, yeah, import static dot, not import static. What did you import? Remove that. For collection, let me write it. Hopefully it will figure things out. Collection dot, where are you? Okay, remove that one. Collection dot modifiable map of data. And now hopefully it understands what do I want, and it didn't, because I forgot an S here. Collections from Java util, unmodifiable map of data. ToString is the same thing. We want a codec and a read and write NBT for this guy. So for the codec, I will say public static final codec of Blackboard codec, and it's not that anymore. We can't use record codec builder. Instead, we say codec dot unbound map codec dot string comma Blackboard entry dot codec. So that's the map. Then xmap, and here we say Blackboard from map, and then Blackboard as map. So basically we need to write these two methods so that we can handle the conversion with ease. I'm not sure if it was needed or not, but I'm writing it to make it bulletproof. So here we get the data, but we say public, that returns again the same thing actually, but we call it as map, and here we directly return not that, the data directly. Okay, so that's as map. It's easy, it will work. But from map, I will add another, now let's make it public, and I will add another public one. So public static returns a Blackboard, and we call from map. Here we want a map of a string comma Blackboard entry, not a class, goddammit, and we call it map. Here we say Blackboard board equals to new Blackboard board dot data dot put all from the map, and finally return the board. Simple enough. Now that we have all of this, I can read and write the NBT. For read and write NBT, we will say public that returns NBT compound, write NBT, and we are not accepting any NBT compound here. We say NBT compound equals to new compound. Then we say codec dot encode start with NBT ops dot instance, and this. After that we say dot result or partial, and here we can provide something that will print anything, and we say system dot error println. So if any error happens, we will see it at least inside our console. This will not work in the game environment, but in dev environment, I think. I'm not sure about that one. If present dynamic, use a lambda. Here we say if the dynamic instance of the NBT compound, and we call it NBT, then we want to say for string key inside the NBT get keys, we say compound that we had on top, dot put the key and NBT dot get from key. At the very end, we want to return the compound. This is our write NBT. Now read NBT is much simpler. Public, and I'm not gonna make it static. Blackboard, we call it read NBT from the NBT compound. Actually, let's make it static. This will help. And the reason is that we can say our Blackboard equals to the Blackboard dot blah, and not this dot Blackboard. I'm not sure about that one. Do we want to have it as a static? It doesn't change anything. Okay, so remove the static, and here we say return codec.parse using nbt ops.instance and the nbt, and we call this one nbt here. And finally we say get the result, and finally or else get Blackboard new. We try to read the NBT and get the Blackboard. If we fail, we return a new Blackboard, an empty one. So this is the read and write NBT for the Blackboard. Now we go back into logic tree. We want to have a read and write NBT here, and for the nodes. Now to write it here and read it here inside the tree, we will say public NBT compound write NBT. And no, we don't need the compound to be here. So we say NBT compound NBT equals to new one, and then we say NBT dot put the Blackboard with the Blackboard dot write NBT. And then we need to handle nodes here. How However, I will bypass it right now. So we return the NBT, and I will put a note here that says write nodes, and then public void read NBT. Actually, this time we need that NBT tag. So NBT, we will say if NBT contains the Blackboard, we want to do things. First one, we say Blackboard.clear. So we clear the current Blackboard that we have. Then we say Blackboard, let's call it loaded so that we won't do this. We say equals to Blackboard. Here is the reason I had it as static. Okay, read NBT. And yes, it says that make it a static. That is why I had it in my notes. So NBT dot get compound, and the compound will be the Blackboard. That's that. Now this has a problem here. It says that optional. We will fix that in a minute. Then we say Blackboard dot get data dot put all from loaded dot get data. Now let's fix this one. To fix it here, because we have optionals, we need to say loaded equals to read NBT get compound. Actually, it should be the same thing. So we will make things a little bit different here to handle the optional. So we say optional of NBT compound, call it optional equals to NBT.getCompound for the Blackboard. Then we say optional dot if present the, what should we name it? Blackboard. No, let's say it loaded goes into, actually I need to change it, compound. Then we say loaded for the Blackboard equals to, actually we want to read it. However, here we say compound, and this will solve that optional, and then we will clear and we will assign. If this fails, we won't clear our blacklist anymore. And that's our read NBT. Now let's go for the node, because as you recall, nodes having Blackboard, and we need to handle the read and write NBT here too. So we say public NBT compound, and we call it write NBT, and then another one for public void read NBT that accepts the NBT. Okay, for writing, we say NBT compound, NBT equals to new compound, then we say if not children dot is empty, because if it's empty, we don't have anything else to do. At the end, we return the NBT. If we have things inside the children, we say NBT list, children list equals to new NBT list, then we go for node T inside the children. We say children list dot add the child write NBT. At the end, we put it as children. And finally, we return NBT. Now here we say read NBT, we say if NBT dot contains. Now contains only accepts a key, nothing else, and the key here is children. So if you have children, then we say NBT list, the children list equals to NBT dot get list. For the children, we need to provide something here, and that is NBT compound. What was the thing? NBT type dot compound. What's wrong with you? It says remove redundant argument. So get list now is optional again, and we need to handle it. So again, I will break it to multiple lines to make it much more readable. So we say optional of NBT list, children equals to that, and we don't need to provide the type anymore. Let's work with children name, because I was debating on children list name. It has an optional. Anyway, we say children list dot if present, and here we are going for children. Then we go not like that. We open a curly brace, we move it to the new line, we end it there. Here we say for int I equals to 0, I is smaller than children's size. Then we say children.get I.read NBT. And here things are getting a bit different, so I will call it list, because we have children on top and this is causing problem. And here we say list.get compound at index I. And in theory, this should solve everything. And what's wrong here? Again, I'm dealing with optionals here. So let's open a curly brace, close a curly brace, and here again we say optional of NBT compound, and let's call it child equals to that. Let's rename it to child compound. And finally, we say if child compound is present, child NBT, whatever goes into, we say children dot get at index I dot read NBT for the child NBT. What's your problem now? Okay, I did do things wrong. I should say you don't need this if here, and this is if present. That's it. Okay, now what's wrong with you? Why don't you get the I? Variable used in lambda expression should be final or effectively final. Let me first fix something here. I is smaller than children dot size. So that's that. Now we are getting the compound that I. We say this dot if present goes into children dot get I. Okay, I can export it into a variable. Okay, so I say dot var and no, there. Okay, and we call it child. Read NBT. What are you saying? That replace lambda with method reference. That's for the whole thing. Okay, now that we are reading and writing NBT on any node, we can go back into our blacklist and take a look at what we had here as a to-do. Did I miss to put it? Actually, on the read NBT, we have things to do here. So we say if NBT that contains, yeah, I have to do it. Start node, we want to cover that, and our start node, where is that? Actually, not in Blackboard. God damn it, where am I looking at? I want the logic tree. So when I'm reading the NBT at the end of everything, yeah, here that is that to do write nodes, okay? And we say if NBT contains the start node and start node does not equal to null, then we want to say start node dot read NBT with the NBT dot get compound for start node, okay? And to avoid typos there and here, I will use that. And again, we are dealing with optionals. To fix this, I will open and close a curly brace here. And here we say optional of NBT compound, optional equals to that. Instead of that, we say optional dot if present NBT goes into, oh, I should rename this guy. Let's call it compound. Goes into start node dot read for the compound. That is handling it there. Now for writing, we want to write it. So we say if start node does not equal to null, we say nbt dot put start node and the start node dot write nbt. That was a lot of things to cover, and thankfully our node will look into every child and bind everything inside the list, and at the end returns a single compound, and when it's reading things it will handle it properly. So we don't need to parse the whole tree this way. I think finally we are able to read and write our compounds and NBT inside the system. However, remember in your JiTickLogic implementation class, you need to have a read and write, and from your block entities read and write, you need to read and write NBT on the tree. So don't forget that. It's up to you. I can't handle your block entity and I can't handle your implementation of JiTickLogic. So all I'm providing is the ability to call a single liner code like this or like this. Okay, so you will just say that, hey, read NBT compound on the tree and it should be able to handle it. Or actually, when we are writing, it will return an NBT compound, so you will write it. Anyways, that is it for the serialization. I did handle the serialization before going for other nodes, like whatever I was planning, I lost the track, but in the next video, we will come back to those nodes. The reason I wanted to handle NBT was that at any time before making complex things, it's a very good idea to finish your infrastructure and then proceed forward. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.